Welcome to our today's lesson in this YouTube channel. We are going to look at mainly acids and how they react with bases, how they react with metals and carbonates. We can remember in our Form 1, we defined an acid as a substance that produces hydrogen ions when dissolved in water. So hydrogen is positively charged. And whenever you dissolve a substance that dissolves hydrogen, it becomes an acid. Now notice that for an acid to be an acid, the positively charged ion has to be only hydrogen. It has to be hydrogen. For example, you have the case of sulfuric 6. You have nitric 5 acid and hydrochloric acid respectively. When they are dissolved in water, they produce hydrogen ions. So these hydrogen ions are positively charged altogether, but the other part is negatively charged, either of them. So these negative charges or these negatively charged ions are called anions. Now in this case of nitric 5 acid, we have a nitrate, and this is a radical. Unlike hydrochloric acid, which only produces chloride ion and it is not therefore classified as a radical. We can see another example of sulfuric 6 acid. So in this case, you have our sulfuric 6 acid being dissolved in water, and then it is changing from the liquid state. The status symbol there is liquid, meaning that it's very concentrated. And then you have your water molecules, and it produces two hydrogen ions. Those two hydrogen ions are present here in our liquid, and then a sulfate ion aqueous. So we change from liquid to aqueous state. So here what we have is sulfuric 6 acid separating into two, a radical called sulfate and two hydrogen ions. And the same thing also happens to nitric 5 acid. It will change from its liquid state, and then after changing from liquid state, it's going to form a hydrogen ion and a nitrate ion. This is a radical, and this is not a radical, but it's just a cation, the hydrogen ion. So the next thing that we need to ask ourselves is, how do acids react? So acids react with metals, carbonates, and bases. Now with metals, there's something we call reactivity series, a series in which the reactivity of metals is shown. And according to reactivity, metals are arranged from the most reactive to the least reactive, the most being potassium and the least being gold. Then hydrogen occupies a position between copper and lead. And this position means that all metals that are below hydrogen cannot react with dilute acids, and all metals above hydrogen can react with dilute acids. And note, concentrated acids can react with all metals, but dilute acids cannot react with all metals because the hydrogen will not be replaced by a metal like copper, which is below it in the reactivity series. Now, in our case study here, the reaction between an acid and a metal produces two products. It produces two products, produces salt, and it also produces hydrogen gas. And because it is a gas, you are going to observe bubbles, or you can say effervescence. Bubbling or effervescence, should you forget bubbling, you can say effervescence. Should you forget effervescence, you can say bubbling. But never say fizzing to mean production of bubbles, because fizzing means sound. Fizzing is a sound like the one that is produced when you have your soda. We can have another reaction, for example, the reaction between zinc and sulfuric 6 acid. So far, we have only looked at the observation that involves production of a gas. For example, in this case, we have our hydrogen. The observation, we call it effervescence. But also, acids reacts by also producing heat. They also produce heat, and such a reaction is normally called exothermic. You can use the letter E to mean exothermic and then another X to mean exothermic. So the observation for reacting acids and metals are mainly two. You have bubbling, production of a gas, and you have production of heat. That is to mean the reactions are exothermic. Now, when you talk about the salt that is being produced, again, there are two kinds of salts. We have salts that are soluble and salts that are not soluble. For example, in the solubility test, all salts of group 1 elements are soluble, and you also have salts which are not soluble, for example, calcium sulfate. And in our next example, we have sulfuric 6 acid reacting with sulfuric acid in another reaction, maybe reacting with oxides and hydroxides. So here the products will again be two of them. But unlike when you react an acid with a metal, when you react with bases, water will be produced instead of hydrogen, but the salt will remain. So when you react your copper 2 sulfate, when you react to a sulfuric 6 acid with copper oxide, you'll get copper sulfate and water. Now, copper 2 oxide is normally black, but copper 2 sulfate aqueous is normally blue. So here the observations again are two. You will have the color of copper 2 oxide changing from black to blue because copper 2 sulfate is continuously being formed. And as this copper 2 sulfate is formed, the blue color will increase in magnitude. And then remember that it's only blue if it is in aqueous state. If you are to evaporate all this water, you're going to remain with a white residue because copper 2 sulfate is blue in aqueous state because it is hydrated, and once you remove water, copper 2 sulfate becomes anhydrous. All water is lost, and that water that is present in that salt, we call it water of crystallization. We call it water of crystallization. So we are going to conclude there. Feel free to comment, ask, and subscribe.